This is section 1.2, visualizing and graphing data. These are the topics we're going to cover during this brief period. We're going to start with an example of analyzing one variable data. We're going to give the following numbers: negative 8, 25, 13, 2.5, negative 9.6, and 3.1. And we're going to be asked to find the maximum, the minimum, the range, the median, and the mean. Now, when we first start doing this, one of the best ways to organize your data is to start by rearranging it. We're going to do that by putting it in ascending order. So we have negative 9.6, negative 8, 2.5, 3.1, 13, and 25. When we do that, we quickly see that the minimum value is negative 9.6. The maximum value is 25. To get our range, that's simply your maximum minus your minimum. Just need to remember to distribute the negative sign. So this is 25 minus negative 9.6, which gives us a 34.6. Now the medians are middle score. However, we have an even number of data points here, so we have to average the two. So 2.5 and 3.1 are my two middle ones, and the average of those is 2.8. That would be my median. And my mean is just the sum of all of these divided by the number of data points. So I'm going to add all these together and divide by 6, and we find out that our mean is actually 3.5. Now, as we approach two variable data, one of the things we want to start talking about is a relation. And a relation is basically a set of ordered pairs. And that's typically denoted in the form x comma y with parentheses around them. Now we again have to start with definitions, and we start by defining domain as the set of all x values in a relation, where the range is the set of all y values in a relation. A simple example would be a set of points. So if I look at the relation, a set is usually denoted by squiggly brackets. So I have the squiggly brackets and a list of points. This is a data set. I have the point 1, 4, the point negative 5, 3, the point negative 4, 0, the point 5, negative 2, the point negative 3, 0, and the point 0, negative 5. So my domain are going to be all my x values or all my first values. And typically when we write domain and range, we do them in ascending order. So your domain is negative 5, negative 4, negative 3, 0, 1, and 5. Notice there are 6 elements in your domain. Your range is negative 5, negative 2, 0, 3, and 4. Notice there's only 5 elements in your range. The reason there are fewer elements in your range than your domain is that we simply do not list items twice. So the 0 that appeared in the range for the point negative 4 is 0, and the point negative 3, 0 is only listed once. Now I can also visually represent this relation by simply showing the graph of this relation. All I'm doing are plotting my data points. This is the point 1, 4. This is the point negative 5, 3, negative 4, 0, negative 3, 0, 0, negative 5, and 5, negative 2. This is my x-axis running horizontally, my y-axis running vertically, and these x and y-axis split this graph into quadrants. We start in the upper right with quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We'll use more of this later, but just to kind of detail it now. Please note that anything that falls on the axes are not considered part of a quadrant. Your axes are your boundaries and are actually not part of the quadrant. Now when we're talking about ordered pairs, one of the topics we want to also discuss is the distance formula. I can find the distance between 2 points. If I pick one point, x1, y1, and another point, x2, y2, notice the 1s and the 2s here are subscripts. This just says that I have my first point. This is the x value of the first point, the y value of the first point. This is my second point. This is the x value of the second point, the y value of the second point. Here are the 2 random points I picked. Here are the x values here. Here is the absolute value or the distance between the x values. To get the distance between the x values, I simply subtract. Here are my y values, which correspond to these points. And again, to get the distance between the y values, I simply subtract the y values here. Your overall distance between the 2 points is the square root of the distance squared between the x's plus the distance squared between the y's. In other words, if you see the way this is written, this is actually a Pythagorean theorem. This is the distance between the x's, that's this piece. This side is the distance between the y's, that's that piece. And if you remember your Pythagorean theorems that a squared plus b squared equals c squared, well, in this case, your c is just we're not using c as hypotenuse, we're using d as the distance, and these are your two sides. Well, how does this work? Let's look at an example. If I want to find the distance between 2 points, negative 2, 1, and 1, 4, I simply plug into my formula. My x1 is negative 2, my x2 is 1, so this becomes 1 minus negative 2. We need to remember to put parentheses around here so we distribute our negative sign. Your y2 is 4, your y1 is 1, so 4 minus 1 squared. So this becomes the square root of 3 squared plus 3 squared, which is the square root of 9 plus 9, which is the square root of 18. And we can round this to 4.24 to be our distance. Another formula we use when we're dealing with points is it's called a midpoint formula. Basically, if I have 2 points A and B, your midpoint is the point that falls exactly halfway between them. And your formula for your midpoint is very simple. It's simply x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Basically, if I add two numbers together and divide by 2, that's the average. So the midpoint, the x value is the average of the x's, the y value is the average of the y's. So if we look at applying this to an example, if I have 2 points, 2 comma 1 and 6 comma 3, the midpoint would be 2 plus 6 divided by 2, because that's the average of my x values, and 1 plus 3 divided by 2, because that's the average of my y values. So 2 plus 6 divided by 2 is 8 over 2, which is 4. 1 plus 3 divided by 2 is 4 over 2, which is 2. So if I look at my graph, sure enough, 4 comma 2 is the exact halfway point between that. Now the last formula we're going to cover in this section is the circle formula. A circle is defined to be the set of points that are equidistant from a fixed point, and that fixed point is known as the center of the circle. And if I know the center of the circle to be the point h comma k, and I know the radius of the circle is r, then the formula for every point in that circle can be given by x minus h quantity squared plus y minus k quantity squared equals r squared. So here, my h and my k are my center. Notice these are negative signs here, okay? So we have to adjust if we see something slightly different. I'll go into that in a second. And this right-hand side is r squared. It's not just r, so whatever the radius is, I'm going to square it. Let's see how this works. Write an equation for a circle with center negative 1, 0, and radius of 8. So I start with my formula, x minus h squared plus y minus k squared equals r squared. So there's going to be x minus negative 1 squared plus y minus 0 squared equals 8 squared. Notice all I did was plug in for the h, the k, and the r. Now notice because this is negative, the x minus negative 1 becomes x plus 1 squared plus y squared equals 64. So this is my equation. Notice I can also work backwards. I can sit there and say, well, if I wanted to put it in this form, the h, this is x plus 1, the h would be negative 1. This is just y squared, so that means the k is 0. So negative 1, 0 is the center. And if I take the square root of 64, I get 8. The radius is 8. Similarly, I can do this on other problems. If I'm given this equation, in this case, I have the equation x minus 5 squared plus y plus 4 squared equals 49. I want to find the center and the radius of the circle described below. Well, the center, this is x minus h. In this case, it's x minus 5. Notice the signs are the same, so h is 5. Here's y plus 4 and y minus k. The signs are opposite, so instead of positive 4, k is negative 4. And similarly, this is 49 is r squared, so r is simply the square root of 49, which is 7. So my center is going to be 5, negative 4, and my radius is going to be 7.